We had a request to do a mechanism from fall 22, test 3, the first one. This is making a vicinal halohydrin, which is what we have here, vicinal halohydrin. But this test is reminding you, when you started with the triple bond, the hydrin, which is an alcohol, is attached to an alkene. And you know that that's a new functional group that doesn't like staying enol. It doesn't like staying enol. It'll become a ketone. And that's called tautomerization. And in this one, you better use the acid catalyzed version, because I see this molecule here. Is that an acid or a base? It's an acid. Okay? I'm going to use the acid as the catalyst and its conjugate base as the base. But let's get busy. The number one mistake I see in reactions where a halogen is mixed with water is that students forget to react the halogen with the water first. Water has surrounded this halogen for months, and it's been in the bottle in the back room, and it reacted with it months ago. H2O reacts with your halogen like this. And you put the halogen near your alkyne and put the water on there. Don't forget, you're going to need a lone pair to finish your triangle. Yep. Pi attacks the halogen, water leaves. Lone pair generally comes back to the more substituted carbon, but in this example, it doesn't matter. The substitution is the same on each side, doesn't it? So you come back to one of the carbons. You pick. Make a triangle, please. Triangle. Phenyl groups. Don't forget, this triangle has real bonds. Real bonds to a chlorine that has a plus charge. You also made water. But there's also a lot of water around, so you don't have to wait for the water. Water generally will attack the more substituted carbon, but we've already had this discussion, right? There's no more substituted carbon in this example, so pick a carbon. Sorry about that. I'm going to pick the top carbon. That's not about top and bottom. One of the carbons is all. Backside attack. Chlorine tries to leave. Can't quite leave because it's attached twice. Phenyl. Cl's here. Double bond still there. Other side of the pi is your OH2. And your phenyl's up here now. I got booted upstairs. Don't forget the plus on the oxonium. Why is this the correct product to circle? Circle a major intermediate. Explain your choice. Backside attack. Backside attack. This is part of B. Yields anti-result. Anti meaning OH on one side and Cl, right? And what's going to take this H off of here and give me my enol? What's the best base I have around? Cl minus is not as good a base as water. pKb 14 minus -5 is 19 versus water 14 minus -3, which is hydronium, right? So 17 is a better base than 19. pKb, sorry. And then You want to do yourself a favor. I apologize. I should have had the H bonded to the O there. I'm going to get rid of the H there. Get my highlighter back. There you go. Some kind of base is going to grab that H. And the acid is going to provide a proton. Oh, acid is going to provide a proton for the alkene right there. The base is going to take the proton. You got everything you need there. Acid-base conjugate pair. Do you see it? You need an acid-base conjugate pair for tautomerization. They got to be relevant for the question you're doing. They're definitely relevant. They're both here. Lone pair on water grabs the H from the enol. Sigma becomes pi. There's your ketone. Old pi picks up a proton from the conjugate acid in the catalyst. See all those arrows flowing away from each other? Yeah, I know we haven't done our labels yet. When you're doing your labels, remember, arrows start at nucleophile. It says nucleophile. You love a nucleus. What are you when you love a nucleus? I am electrons. Okay, nucleophiles donate electrons. Lubnu. They're synonymous. Lewis base nucleophile. So I'm just going to go at the start of every arrow and put Lubnu without even thinking. Labels in purple. I might be adding some Bronsted stuff later. Here's a Lubnu. Here's a Lubnu. Oops, doesn't go there. There's a Lubnu. And there's a Lubnu right here. And the things that Lubnus are attacking are always ELAs. Electrophiles are always Lewis acid. Electrophiles are always Lewis acid. Electrophile is always a Lewis acid. Electrophile, always a Lewis acid. Now, if your Lubnu is attacking a proton, then it's a Bronsted situation. So look at all your Lubnus. Every time they attack the proton, you say they're also a Habibi. Habibi. And we'll put BB in orange. And this Lubnu is not attacking a hydrogen, so it's not a Habibi. This is not attacking a hydrogen, so it's not a Habibi. This thing's not attacking a hydrogen. This Lubnu is attacking a hydrogen. It's a Habibi. Bronsted base as well. And this thing's giving up a proton. It's a Ba. And watch this one. Lubnu BB. And I forgot to label up here. Ela Ba. Ela Ba. But look down here. Here's an attacker. In the same reaction, this thing's an attacker. What's it attacking? A proton. Lubnu's a Habibi too. And the thing being attacked is an Ela. And it's getting a proton attack. It's a Ba. Ela Ba.
Did you think the chlorine on the very end, where you said if the person's attacking it, the thing that's attacking it is the Alkyne and
Oh, you're talking about this coming back as maybe a Lubnu too?
Yeah.
I would give you something because it is coming back. It's like a compensation. I'm going to tell you what, it's not going to happen on Wednesday because I promised you your labeling one. It's now official. Your labeling one was either 6.1A or 6.1B, the first two mechanisms of the semester. And I'd like to point out either one of those is also a candidate for rearrangements if they're possible. Remember, those are the two cation mechanisms, carbo-cation mechanisms. Those are your rearrangement mechanisms that are possible, right? So I'm not gonna, she was asking, should I put a Lubnu on here? And I would have accepted it on this test. And on this carbon, you better write ELAP, right? But it won't be happening on Wednesday anyway, so don't stress out about it. Okay, you don't have that step for either the HCl reaction or the water and sulfuric acid reaction. You don't have it. So there you go. Did we do an adequate explanation? Explain my choice, major product. Yeah, I only had to explain between these two. And backside attack gives anti. That's the only difference. Okay, I'm happy with this one.